This is Chemistry Made Simple YouTube channel. I take this opportunity to welcome you to another great learning segment. Today, we concern ourselves with the nomenclature of organic compounds known as alcohols. What are alcohols? A simple definition is that the word alcohol, or alcohols for that case, refers to a homologous series of organic compounds that contains or bears the hydroxyl group or OH group, as you may call it, as the principal functional group. Displayed besides there is the general formula that represents our homologous series of alcohol. Following from the displayed formula, the second formula is preferred as compared to the first formula, since it clearly and distinctively shows our functional group, and in this case, the hydroxyl group. From the displayed formula above, specifically the second formula, when N is equal to 1, then the alcohol we obtain is displayed there and is commonly known as formal alcohol. And when N is equal to 2, the alcohol that is obtained from the general formula 2 is displayed there and is also commonly known as acetyl alcohol. At this point, we are not interested in knowing the origin or the criteria of the names formal alcohol and acetyl alcohol, but we are rather interested in learning the correct and accepted systematic procedure that is used to name our class of compounds, alcohols. How do we name alcohols? Alcohols are named by following guidelines from Iupac, just like all the other homologous series of organic compounds. Guideline number 1 is that, as a general rule or format, the name of an alcohol is derived from the name of the corresponding alkane by replacing the suffix E in the name of the alkane with the suffix OL. In this guideline, it is important to understand the meaning of the words corresponding alkane. This simply implies an alkane having an equal number of carbon atoms, just like the alcohol. In order to illustrate what is meant by guideline number 1, displayed besides there is the alcohol that is known as methanol, and also displayed there is another alcohol that is known as ethanol. Note that the two displayed alcohols there correspond to the alkanes methane and ethane. Second guideline is that when you are naming an alcohol, always use the format displayed there, especially if it is a long chain alcohol. In the displayed format, the word alkane is derived from the corresponding alkane. I hope you still remember what it means by corresponding alkane, as previously explained. And the lowest locant of the OH group is obtained by assigning numbers to the carbon chain of the alcohol, starting from the end of the chain that is closest to the OH group. We need to practice the format displayed there by using our displayed compound there. Now, if you carefully observe the compound, is that the numbering is going to be from the right hand side of the chain. Why? It's because the right hand side of the chain is closest to the OH group as compared to the left hand side of the chain. Therefore, after numbering the carbon chain, we obtain that the functional group OH group is on position number 3, and the total number of carbon atoms in the chain are 7. So the corresponding alkane in this case is heptane. From heptane, we obtain the prefix heptane. So our name is therefore going to be heptane hyphen 3 hyphen OL, and is simply pronounced as heptane 3O. Second example, to illustrate the above format in guideline number 2, displayed there, we do have our alcohol that is having 5 carbon atoms. Now, notice that the OH group in this alcohol is at the start of the chain. So our only choice of numbering is from the start of the chain as displayed there. And therefore, the name of this alcohol, by basing on the above format, is going to be pentane. Pentane has been derived from the corresponding alkane of this alcohol, which is pentane hyphen 1 hyphen OL, which is simply pronounced as pentane 1O. In the part above, we have been learning how to name straight chain alcohols. In the next part, hereafter, we learn how to name alkyl substituted alcohols. According to Iupac guidelines, alkyl substituted alcohols are named as follows. The first guideline is that we must always determine and locate the parent chain in this alcohol, and do not forget that the parent chain in this case must be the longest carbon-to-carbon chain that is in the alcohol. We shall practice this several times. The second guideline is that if there are similar alkyl substituents in the alcohol, we must indicate these similar alkyl substituents with prefixes di, implying 2 similar alkyl substituents, tri, implying 3 similar alkyl substituents, tetra, implying 4 similar alkyl substituents, and so on, as derived from Latin. The last guideline is that presence of different alkyl substituents on the alcohol is indicated by writing these alkyl substituents in alphabetical ranking. We need to practice all the rules and guidelines that we have looked at above. Our illustration number 1 displayed there is that first and foremost, after observing our compound, we must identify the parent chain. So, what is the parent chain? As I have always advised you, it is important for you to transverse the compound and determine all possible carbon-carbon connections. And from all the possible carbon-carbon connections, the carbon-carbon connection that has the highest number of carbon atoms is the parent chain. This being said, going back to our compound, the yellow highlighted chain is the parent chain. After determining the parent chain, we have to assign numbers to our parent chain by starting from the end of the chain that is closer to the OH group. So you can see that the left is closer, and if we assign numbers like displayed there, we establish that the functional group, OH group, is on carbon number 2. But on carbon number 3, we do have a methyl group, and on carbon number 4, we have an ethyl group. We are now able to write down the name of our compound as 4-ethyl 3-methyl heptane 2-O, which we pronounce as 4-ethyl 3-methyl heptane 2O. Second illustration there, first and foremost, observe the compound. According to the guideline, we are supposed to determine the parent chain in the compound. So, as I advised you in the previous illustration, is that always transverse the compound, determine all possible carbon-carbon connections, and from those carbon-carbon connections, the one that has the highest number of carbon atoms becomes the parent chain. So without wasting time, the yellow highlighted chain or carbon skeleton is our parent chain, which by the way is having a total of 5 carbon atoms. Now we are supposed to proceed to the next step, which is assigning numbers to our parent chain, but we should always start from the end of the chain that is closest to the OH group. So starting from the right hand side of the chain, you have seen that the numbers have been assigned to carbon atoms. Now on position 3 of our chain, we do have an ethyl group, but we also have a secondary propyl group. So at this point, we are able to write down the name of the compound by respecting the fact that these two are alphabetically different and we must rank them alphabetically. Therefore, the name is going to be 3-ethyl-secondary-propyl-pentan-1-O, which is simply pronounced as 3-ethyl-secondary-propyl-pentan-1-O. Note that secondary propyl is also known as isopropyl, and therefore the compound can have another correct name, which is 3-ethyl-isopropyl-pentan-1-O, simply pronounced as 3-ethyl-isopropyl-pentan-1-O. At this point, I want to thank you for paying attention, and I take this opportunity to welcome you to the next interesting part of our topic, which is the chemistry classroom. Welcome to the classroom, and before us we have a problem or a challenge where we're supposed to name the following compounds. Of course, as I have said, is that whenever I say you are naming, you are strictly following these guidelines here. So those are the guidelines that we are going to follow in determining the correct name of the given compound there. So according to Iupac, when we are naming this compound, our first guideline is to determine the parent chain. The parent chain in this case is going to be the longest carbon-carbon skeleton in the compound that is having our functional group. Notice that this is our functional group. So before determining the parent chain, always transverse the given compound and obtain all the possible carbon-carbon connections. From those possible carbon-carbon connections, the one having the highest number is the parent chain. Without wasting time, this that I have enclosed in red ink is our parent chain. Why? Because it is having the highest number of carbon atoms and also as our functional group. By the way, our parent chain has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon atoms. After doing this, our first guideline is done or complete. We go to the second guideline. The second guideline directs us to number our carbon chain. But when we are numbering the carbon chain, the guideline says we should start from the end of the chain. There are two ends of the chain. There's this, and there's also that one. That we should start from the end of the chain that is closest to the functional group, because our functional group is the priority in this case. So without wasting time, we are going to number from this side. So this is carbon atom number 1. This is number 2, number 3, number 4, 5, 6, 7, 8, 9, and finally 10. Now, after numbering our carbon atoms, the numbers that have significance is the number 3, the number 4, we have the number 6, and also the number 8. So from this, we can be able to generate the parent name or the parent chain for that case. So since it has 10 carbon atoms, this is, and then on position 3 we have our functional group. After identifying this, we can now therefore be able to write the name. But before we can write our name, let us also establish the fact that we have 3 similar methyl groups. This is also a methyl group, and so is this. So without wasting time, the name of our compound is going to be 4, there is a methyl group, and then 6, and then 8, then a hyphen. These are 1, 2, 3 methyl groups. So therefore we use the prefix tri, and then methyl, followed by the parent name or the parent chain, which is as simple as that. For matters of emphasis, I will encircle the name of our compound in blue ink. Part B here also, we are supposed to name the displayed compound there by following guidelines from Iupac. Is that our first guideline is to determine the parent chain, and for that case the parent name. Now notice that this is a cyclic alcohol, and therefore our parent chain, and for that case the parent name, is going to be cyclohexanol. The second guideline is that we have to assign numbers to carbon atoms on our parent chain. And since it is a cyclic parent chain, the direction of numbering can be in the anti-clockwise direction or in the clockwise direction. But before we determine which of the two directions to use, the direction we choose is the one that will give these two substituents the lowest numbers possible. And by using that hint, this is our direction of numbering. Since our two substituents are now on position 2 and 3, if you had numbered in the anti-clockwise direction, this would have been position 4 and position 5. That being done, the numbers 2 and 3 are very special because on position 3 we have a methyl group, and on position 2 we have secondary propyl group, or some other sources of chemistry literature also call it isopropyl. After identifying those facts, we proceed and write down the name of our compound by following the alphabetical arrangement of the two groups. So therefore, the first name that I have here is 3-methyl, and then 2-secondary propyl, followed by our parent chain or parent name, cyclohexanol. Alternatively, the other name is 2-isopropyl, 3-methyl, cyclohexanol. In order to emphasize our answer, let me encircle it in blue ink. As simple as that. Do you have any challenging concept as regards organic nomenclature? Please contact me by email using the email address in the description of this video, and I will humbly respond to you. Until next time, I remain yours faithfully, your chemistry teacher. Goodbye.